our very great pleasure today to have a very good friend of ours as a guest, as a speaker. Is Michel Ghins from Emeritus from the Catholic University of Louvain. I think most people know him, but perhaps I can just say a couple of words of introduction for those who don't know him. Before teaching for many years at the Catholic University of Louvain in Belgium, he has taught at the State University of Campinas in São Paulo, Brazil, and he has also been visiting professor at many universities like Catholic University of America, the University of Pittsburgh, of Oxford, and Torino. He is currently Vice President of the International Academy of Philosophy of Science, and he has written an important book on inertia and space-time absolute Newton, and from Newton to Einstein, philosophical analysis, published with the Académie Royale de Belgique, and he has also written an introduction to the philosophy of nature, representation, realism, and scientific laws in Portuguese. He has been editor of the Bibliothèque Philosophique de Louvain, of the Revue Philosophique de Louvain, and of the many collected books. Michel has written many articles on scientific realism, on metaphysics of science, and on various fields in the philosophy of science. This is not the first time he lectures in Urbino. Perhaps this is the first time he virtually lectures in Urbino, but we had the pleasure of hosting him other times in the past, and as I said, we are a very good friend, and we have been cooperating in many ways. So this is a nice moment for us, and I'm very glad to leave him the floor. Vai pure, Michel.
Grazie Mario, è un piacere di parlare in vostri seminari. Purtroppo non è possibile di essere presente in Urbino, una città che mi piace moltissimo, e essere con voi, però grazie alla tecnica è possibile fare qualcosa. I'm going to speak in English. So the title of my talk is about it's a wet metaphysics for the laws of nature. And the plan, do you hear me?
Yes.
Okay, good. So first of all, I'll explain what I mean by a law, and I will distinguish between scientific laws, nomological formulas, and laws of nature. I think there is a lot of confusion on this terminology here, and this is very important for the philosophical issues connected with it. Then I will briefly present what I mean by a fact, a particular, and the truth of a proposition. Then I'll defend a propositional view of laws, and defend that natural powers are the driving force of change and movement in nature. And then I'll discuss in what sense we can deem laws, scientific laws are not necessary, and nomological formulas are not necessary, but laws of nature are indeed necessary. So first of all, what is a scientific law? So I take a scientific law to be a universal proposition. And the proposition is just a semantic content of a statement, which belongs to a well-established theory, and for which we have more reasons to believe that this proposition is at least approximately and partially true. So more reasons means that we have more reasons to believe it to be true, rather than believing it to be false or suspending our judgment about its truth. So what I defend is a version of scientific realism, epistemological scientific realism, according to which some universal propositions in well-established theories, that is, predictively correct theories, are true. Well, let's take a very simple example. A Boyd-Charles Marriott law, which belongs to thermodynamics. So the proposition is, which expresses the scientific law, is this: all gases in normal circumstances E manifest the Boyle-Marriott formula. Pressure times volume is equal to kT. Okay, so this is well known, but in general, in scientific textbooks, you find the law expressed simply by the formula PV is equal to kT. PV is equal to kT, the mathematical equality. I will define it as being a nomological formula. But the complete scientific law must say that this formula is satisfied by some entities, it's satisfied by gases in normal circumstances, and not, of course, by solid bodies, although those solid bodies, they have a pressure, a volume, and a temperature. So formally, we have this, the formula below. So for all x, there is a k. K is Boltzmann constant. And for all values of p, that is instantiated by x, like it's written here, pxy 1. Okay, for all values of p, values of volume and values of temperature, then the product pi is the product of the values of pressure and the value of the temperature is equal to the product of the Boltzmann constant and the value of the temperature. Okay. So this is, I take it, the correct formulation, the complete formulation of what scientific law is. Now, as you notice, in this formulation, there are no modal operators. This is purely extensional. So it describes a regularity in nature that is regularly at the equilibrium. At the equilibrium, gases instantiate or satisfy the Boyle formula. So E means the environment, that is normal circumstances. I'll be back to that in the sequel. And S is what is called the stimulus or the triggering circumstances. That is, there is a condition for this formula, this Boyle formula, to be satisfied by the gas, and the stimulus in this case, the condition is that the gas is in equilibrium. Okay. So as I said, and I insist on this, PV is equal to KT is what I call a nomological formula. It's not a law. Okay. So more about gases. Gases, of course, instantiate the properties of pressure, volume, and temperature, but they are first of all identified by entities which are typically not solid and which have some properties such as fluidity, resistance, and they can be, well, some of them can be breathed and things like that. So in order for the formula to have content, gas is not defined as an entity which has the pressure, volume, and temperature, because there are other bodies, of course, which instantiate those properties of pressure, volume, and temperature. Also, gases, according to me, do not form a natural kind. As you know, many accounts of laws introduce the notion of natural kind and essences of those kinds, like gases and electrons. They form a kind and they have essential properties. So gases essentially must have, for example, a pressure, but it's not necessary that they have a charge, for example. But I think that the distinction between essential and accidental properties is tricky. And in line with many empiricists, I don't buy this distinction. So I take the word gas, quote unquote, is an abbreviation, just an abbreviation which refers to particular entities with properties always found in association. But it's a fact that there are entities such like gas, which instantiate in conjunction a series of properties. So in general, I'm trying to be as empiricist as it is possible. I'm very close to empiricism philosophically, though I'm not a moderate empiricist. I'm a very moderate empiricist, as you will see in many instances. So there are no natural kinds, and my account of laws does not rely on this distinction between essential and accidental properties. Also, I don't think that propositions such as electrons have negative charge is a law. By definition, electrons have negative charge, perhaps, though this is debatable, but I won't get into that. They are called by, among others, N.J. Chakravarty calls those laws definitional laws, but I don't think those are scientific laws in my in the way I construe them. Now, the way to identify scientific laws that I propose, namely that there are universal propositions that are considered to be true in the framework of a well-established scientific theory, this way of identifying scientific laws solves the problem of identification. That is, how do we identify scientific laws and distinguish them from accidental laws, like all pubs in England serve draft beer, to take one standard example that you find in philosophy works. Then laws, according to me, then are propositions. They are not facts in the world. So I defend a propositional view of laws, which is opposed to an ontological view. For example, Armstrong, Dresd, and Tooley, they defend an ontological view of laws. For them, the laws are necessary relations between properties, between real properties linked by real necessary relations. That's not my view. So I defend a view which is lawless, that is also called. There are no laws, in the sense that there are no laws in the furniture of the world. Laws are just propositions. And of course, you can ask then, but how is it that there is motion in the world? It's a very ancient problem that was mostly discussed in the antiquity by the Greek philosophers. And so what is the source of the motion in the world? I'll show that is, we don't need laws or as ontological realities, but we need powers. And powers suffice to be the driving force of the course of events in nature. Okay. Now, what makes scientific laws true? I mean, complete laws, they are made true by the existence of entities like gases, some features of environment, and by stimuli or triggering circumstances, but are made true in a correspondent sense, and specifically and importantly by a regular sequence, a regularity of facts, and those are categorical facts. So what are facts? I take facts like Armstrong does to be instantiation or exemplifications of properties or relations. For example, the rose is red. Well, the rose is a particular which instantiates a property, namely of being red. And I defend the realist view of properties that I'm not going to defend here, but I think a good reason to believe that properties, namely we are talking here about categorical properties, is that we can observe them. We can observe some properties which are instantiated by particulars. So we can observe sphericity, for example, we can observe colors, but, and I will contend, and this is controversial, this is more controversial, I will contend that some properties which occur, which are mentioned in scientific laws, are also observable, like mass and charge. I know that it is controversial, but I'll explain. So I'll follow Ellis and empiricist philosophers as well, that in saying that all observable properties are categorical. Okay, that is, as opposed, as we will see, as opposed to dispositional properties and powers. So all observable properties are categorical, and these are the only properties that we have good reasons to believe, in the sense that those reasons are provided by immediate or indirect observation. Okay. Conversely, I say that all categorical properties we have good reasons to believe that they exist are observable too. There might be categorical properties that we perhaps are not in a position to observe, but those are not relevant in this discussion because we have no reason whatsoever to believe that they exist. Now, according to this characterization of observable properties, of those categorical properties as observable properties, the class of categorical properties is not limited to the geometrical and structural properties, which is a standard view. The standard view of categorical properties is that properties are limited to geometrical, like sphericity, or structural, like the organization of atoms in a crystal. Those are structural properties. So I take that mass, charge, temperature, and other properties are categorical observable properties. Why? Let's take the example of the concept of gravitational mass. Of course, the notion of gravitational mass took some time to be understood in the history of physics. But once you know what gravitational mass is, that is, once you have grasped the concept of gravitational mass, then you can, by simple experiences and perceptual experiences, tell whether two masses have different values. For example, if you take two objects which have different values of mass which are significant, like a small sheet of paper in the left hand and your cell phone in the right hand, then you feel immediately that the cell phone in your right hand exerts a force which is larger than the piece of paper in your left hand. So by means of those experiences, and once you have again grasped the concept of gravitational mass, you can assert on the basis of experience the following proposition, or that is, the cell phone has a gravitational mass which is larger than the small piece of paper. Okay, and I think the same is true for temperature and charge, but I want to discuss that now. Now, the issue is, what about very large or very small mass values? Well, those can be measured by means of instruments, the reliability of which has been previously inductively and observationally established. That is, in domains in which the use of the instrument and your immediate sensory experience, in the domains in which the instruments and your sensory experience overlap, you can check that the instrument is reliable, and then you can extend inductively the reliability of the instrument to domains which are not directly or immediately accessible by means of our sensory apparatus. And those are the detectable properties. Detectable properties are properties which are similar, like mass, but very small mass, which is similar as a mass to bigger masses, which we can experience in our environment. And then these are detectable properties, I mean the small or very large masses. So this is a Kitcher's-Galilean strategy to establish the reliability of, for example, telescopes. But this strategy can be extended to other instruments as well. So I'm not going to press this issue further, but I think that it's on the basis of simple experiences, you can extend the domain of observable properties and therefore the domain of categorical properties, not only to not limited to the properties which are geometrical or structural, but you can extend this domain of categorical properties to properties which are mentioned in scientific theories, such as mass, temperature, and so forth. Of course, there are properties in scientific theories which are not detectable. For example, in elementary particle physics, if you take charm or baryonic number, those properties are not detectable. And therefore, according to my scientific realism, these properties, charm, baryonic number, are not real in the sense that we have no good reason to believe that they are real. Okay. Now, the nomological formulas, again, what they do is to describe a set of possible static or temporal relations between instantiated categorical properties. For example, the Boyle formula for so-called perfect gases, that is, gases in normal circumstances. This property is a function, it's a quantitative relation. Pressure, volume, and temperature can take an infinite number of values, and there is a constraint. The constraint is given by the equality. The constraint is that for gases, those values must satisfy the formula. But the formula just defines a set of possible realizations. That is, it's possible because the occurrence of a specific instantiation of this formula, that is, with specific values of PV and T, this realization depends on the conditions, that is, the existence of gases, the existence of gases in equilibrium, the existence of a gas with a specific value of pressure, and so forth. Okay. Same thing with the Newton's formula. Second law, the force is proportional to inertial mass and acceleration. In this case, this formula defines a sequence, can define a sequence of events, that is, a sequence of accelerations that are instantiated by a mobile. So those formulas that occur in scientific textbooks, actually they present set of possibilities with some constraints, obviously, set of possibilities that might be actualized or not. Now the second chapter, according to Armstrong, particular entities, which Armstrong calls thick particulars, and the thick particulars are the usual particulars, that is the objects that we interact with in the world. Those particular entities, they instantiate categorical and also dispositional properties or powers. Okay. Briefly, there are no, according to Armstrong, as well as for Aristotle, there are no thin particulars, that is, particulars that are naked particulars. All particulars are dressed, so to speak, because the thin particular or the bare particular is an abstraction, and all particulars that we are aware of and we can interact with, there are thick particulars. There are always instantiated properties, and those are facts. So particulars, facts, and instantiated properties refer to the same things. Okay. Now the existence of properties, I submit very briefly, can be argued for on the basis of a correspondence view of truth, which is connected but not quite identical with the truth maker principle. If a proposition is true, there must be something that makes it true. I'm not going to advocate for that principle. I'll take it for granted in what follows. So, according to the construal of particular entities or particulars, the propositions are made true by the existence of thick particulars. So the rose is red, or this is red. For example, this is red. A thing which is red, that's a particular, and it's symbolized by P. P means a property, refers to a real property in the world, and A, well, it's an abstraction, is the so-called naked or thin particular. This view, and Armstrong's view, is close to the Aristotelian view, that is, the world is composed of substances with apt attributes. Substances are thick particulars. Okay. Now there is the, of course, epistemological issue. How do we have knowledge of the truth or falsehood of a proposition? That is, how do we know, in case of truth, that a given particular or set of particulars that made the proposition true exists? Now, for categorical properties, there is not much of a problem, because categorical properties are observable, and the truth of proposition about categorical facts can be ascertained by observation. So propositions such like this is red, or this rose is red, or this thing has a gravitational mass, those propositions can be known to be true if we are presented perceptually with roses that are red and things that have a gravitational mass, that have a weight. Now, I think it's important to distinguish, and this distinction is not usually made in the context of discussions of laws. It is important to distinguish to be massive, to have the property of having a mass, and on the one hand, and the property of having the possibility, for example, to attract other massive bodies. The property of having the possibility to attract massive bodies is called a dispositional property or a power. I would call them powers. So having a mass, a body has a mass, at a certain value, a precise value of mass in general, for that matter. A body has a specific value of mass, this characterizes the particular as it is. The property of mass doesn't not indicate any possibility of motion or attraction or whatever of behavior of the body, seems to me. So, of course, you say, well, you know, all massive bodies have the property which is dispositional to attract the possibility to attract other bodies. True. But then, nevertheless, I think it's important to distinguish between the two properties. Now, the main difference between dispositions and categorical properties is, of course, that the dispositional properties are modal properties. They indicate a possibility of behavior for the particular which possesses the dispositional property, but also a disposition or a natural power, that is the dispositions which are mentioned by scientific laws. As we will see, or laws of nature rather, a disposition or natural power such as solubility is not observable. Seems to me it's not observable. Well, there are some philosophers who defend that these dispositions are observable, but I don't think they are. I think empiricists are right on this point. We do observe, of course, that some particulars like pieces of sugar are dissolved in water. That we can observe. We can observe the dissolution, the actual dissolution of a piece of sugar, but we do not observe the possibility it has to be dissolved before it is put in water. However, I think we have indirect reasons to believe that dispositions exist. Why? Well, because of very simple experiences again. Because experience teaches us inductively that entities which are sugar dissolve when put in water in normal circumstances. Okay. Thus, we conclude that if we put this piece of sugar, suppose we have a piece of sugar now and a glass of water, then if we put this piece of sugar in water, it will dissolve. That we will rely on that kind of prediction all the time. And also, it follows that if a piece of sugar, this piece of sugar had been put in water, it would have dissolved. This is a counterfactual, conditional. So if this piece of sugar had been put in water, it would have dissolved. That's a counterfactual which is modal. That is, it means that, well, in this case, if I put a piece of sugar in water, it won't fail to dissolve. It must dissolve. There is no choice, so to speak, for the sugar not to dissolve if put in water. Though, therefore, there is some modality which is included in this assertion, the assertion of a counterfactual, and this is widely recognized. There is some necessity involved. Now, this counterfactual is falsifiable. If I have a piece of sugar and I put it in water and then it doesn't dissolve, and I'm sure it's a piece of water, I checked the properties and so on and so forth, then this counterfactual is falsifiable. If it's falsifiable, when it is falsified, it has a false maker, so to speak. If it has a false maker, when it is true, it must have a truth maker, in virtue of the truth maker principle. In this case, I contend, the truth maker of this counterfactual is a particular PA, where P is a spare disposition or power, and I think, again, this is controversial. This is a non-explanationist argument in favor of the reality of powers, which is based on experience, inductive experiences, and the possibility of falsifying counterfactual conditionals. Some of you, and Mario in particular, they know that I'm a bit reluctant to provide arguments which have the form of an inference to the best explanation. So I'm trying to argue in favor of the thesis I defend by means of inductive reasonings based, inductive arguments based on experience. If so, we can distinguish counterfactuals that, such as if this piece of sugar had been put in water, they're not off, in water, it would have dissolved, is different from the counterfactual. If I had gone out yesterday, I would have taken my umbrella. In the first, there is a necessary link between the antecedent and the consequent, whereas in the second one, there is no such link. And this is usually symbolized by Goodman, Lewis, Bird, and others, by the box, which is the symbol of necessity in modal logic, and the arrow. Now, what are powers and what are laws of nature, and what is the relationship between them? Now, there is a standard way of defining dispositions and powers, by the way, which is found in Bird, among others, which is the following. So you have a box. It is necessary that if and only if X has a disposition to manifest a certain behavior, then in some circumstances, appropriate circumstances, and if there is a stimuli or there are triggering circumstances, then necessarily X will exemplify the corresponding manifestation. Now, applied to powers, the standard biconditional modal definition of a disposition gives the following, and I call powers dispositions, but natural powers are natural, sparse, scientific dispositions which are referred to in scientific theories, and for which we have good reasons to believe that they exist on the basis of the form that I have just given. So we have the following: necessarily X has the power to M, if and only if in the normal circumstances E, and given the triggering circumstances S, then necessarily X manifests M. But as you know, there are antidotes of masse and finks that I'm not going to discuss. The biconditional definition is inadequate, so it can't be accepted, and this is accepted by many, not all, but many philosophers. But there are some of philosophers try to rescue the biconditional definition, but I don't think they are successful. Okay. So if powers are not definable, then powers are primitive. I mean, they are primitive entities. So according to the view of the according to the view that powers are primitive, that is, they are not defined, if a particular instantiate a power, then it has a possibility to manifest some properties, and it will necessarily do it in appropriate circumstances. So we don't have the biconditional, but we have the single conditional, indicated by the arrow here in red. So we replace the double arrow by a single arrow here. Okay. And it is a necessary statement. Now, if powers are not definable, we must have some good reasons that they exist and that they are somehow accessible in experience. I gave an argument in favor of the existence of powers before. but I can insist on this, that we have, given our private experience, we have a, of course, inner experience, that's a private experience, that we have some powers or potentialities, that I have the possibility to raise my arm now, unless I'm prevented to do so, etc. So I have, at least subjectively, a clear grasp, a clear notion, clear meaning of what a power is. And of course, that argument does not count in favor of the existence of powers which are external to me, but I contend that on the basis of the argument that I put forward before, we also have good reasons that there are powers outside us. Okay, so although powers are not defined by other properties, then there are, the meaning is, can be attained. It's the meaning of a power can be attained, and also we have good reason to believe that they exist. Because look, in the formula, I should have said that before, but look, in the formula, on the left hand side, P, that's a power. Okay, so it's a model property. But on the right hand side of the formula, you have the environment, you have the stimuli, you have the manifestation, and all those properties or set of properties, all those properties are categorical properties according to my extended view of categorical properties. And again, among the manifestations of powers, we have the regularities described by the nomological formulas in scientific laws. Okay. Now, for a particular to have a specific power, it must also have intrinsic categorical properties. So this is a necessary condition, but not sufficient condition, because categorical properties are not modal and powers are modal properties. For example, a sphere must be solid to have the capacity to roll. A gas must have a volume to have the possibility to change its volume. For sugar to have the power to dissolve, it must have the appropriate chemical composition, which is usually called the categorical basis of dispositions. But the categorical basis of dispositions, of course, is not modal by definition. For a body to have the power to fall in accordance with Newton's second law, it must have a mass also of some value, which is also, according to me, a categorical property. And finally, the necessity of laws, which is, of course, what we are after. How can we ground the necessity of laws and the necessity of laws of nature here? Because scientific laws are not modal. Classically, necessary statements are statements that are true in all possible worlds. Okay, that's according to Lewis semantics. Necessary statements are statements that are true in all possible worlds. And for Lewis, only analytic and logical statements are true in all possible worlds. So this allows him to define the notion of possible world, and then to define the notion of possible. Possible words for Lewis are the words allowed by the laws of logic and analytic statements. Okay, but for Lewis, possible words are real, and they are real worlds. They are concrete worlds, they are as real as our actual world. Why? This is not, I'm not going to talk about that too much here. But then, if scientific laws are at the beginning defined, as we saw, as universal statements which belong to the scientific theories, this is not Lewis' definition, because Lewis' definition is that scientific laws belong to the optimal axiomatic systems which describe the facts in the actual world. Okay? So my definition of scientific law is not Lewis' definition. But then if we buy the definition of scientific law provided by Lewis, it is possible to the similarity of among possible worlds. Possible worlds are similar basically if they share the same laws, and sharing the same laws, actually this can be in the way Lewis does it. We can do it with my construal of laws and with Lewis' construal of laws. And then dispositions or powers are defined in terms of counterfactuals according to the biconditional definition of dispositions. But that first of all, that definition is not acceptable, as we saw. And second, I don't think we have good reasons to believe that the possible worlds postulated by Lewis have some reality. They must have some reality, because otherwise you don't have truth makers for counterfactuals. Of course, for Lewis, laws are contingent, which is the view I reject. And the way Lewis saves contingency of laws, or humanism in this respect, is by postulating those possible worlds. That is, the possible worlds are the worlds, again, in which the laws of logic are true, and possible worlds are like one to the other. They are similar one to the other if they have the same laws in these real possible worlds. But laws for Lewis are not the same in all worlds. That's why they are contingent. In some possible worlds, some real concrete possible worlds, laws are different from the ones we know in our world. That is, for example, the law of perfect gases could be with the formula. Instead of PV is equal to KT, you could have P square V is equal to KT, or something like that. Okay. Now, I'm not completely against possible worlds, though I believe that the only world that exists is our actual world. So that's the only world that exists. So there are no possible worlds, but possible worlds are a useful fiction. You can imagine those worlds, and they can be a way of speaking. So the possible worlds are very useful for modal logic and the semantics of possibility and necessity, of course. So I don't want to disparage the practical use of possible worlds in Lewis' sense, though I don't believe that they are real, but they are useful in logic and semantics. However, as Putnam famously said, semantics is a bad guide. It's not a reliable guide in metaphysics. From meanings, you cannot deduce. From meaning, reality doesn't follow. So, where are we now? We know that natural powers exist from arguments like the one I proposed earlier in the case of the solubility of sugar. Powers are, according to me, intrinsic, actual properties. They are properties which are instantiated by particulars, and they are intrinsic to those particulars. Powers are basically, they endow the particulars which instantiate them, they endow them with possibilities, which necessarily will be manifested manifested if certain external circumstances obtain. So a particular which has a power P, which is an actual real property, must manifest M in the appropriate circumstances. And in this context, in our discussion, in our present discussion of laws, M is the manifestation of a, is something which is described by a nomological formula. The appropriate circumstances are not always realized. They are sometimes realized. When they are realized, the manifestation will necessarily be realized, but not all circumstances are appropriate. Not all appropriate circumstances are always realized, but they must be possible if the manifestation be also possible. And it seems to me that we can make a good case that ontological possibility and necessity, not formal or semantic possibility and necessity, ontological possibility and necessity are grounded on the existence of powers. So again, a power is, if there are real power, a power gives the particular which has it the possibility to do something or to make a certain irregularity occurring. And also, if a power is instantiated and the appropriate circumstances occur, then necessarily this will happen. Now, formally, what is the connection between powers and laws? So we start with the formula that we discussed before, that the power to M, to a certain manifestation, so if something has a certain power, then again, in the circumstances E and the stimuli S, necessarily X will manifest M. So suppose that we have an X which has the power of 2M, which has the appropriate circumstances are realized, that the stimuli occur, then we have the regularity. Therefore, we certainly have for all X, PMX and EX is equal, and SX implies MX, which is, well, pretty much scientific law. I'll come back to another example later on. Then, since this is true in, as it is called, in all possible worlds, this is necessary. So we have a law of nature. But what distinguishes a law of nature from a scientific scientific law, it is necessity. It's necessity which is grounded on the existence of the modal power here. Okay, which implies. So we have here a strict implication in the Lewis sense, which implies the counterfactual implication, and which is here a counterfactual. And in this sense, we can claim that a law of nature grounds a counterfactual. Okay. Okay. Let's take the example again of a gas. A gas is a particular which instantiates some superficial observable properties, which I call O. Like to be breathable and resistance, but not too much resistance, fluidity, and things like that. And also properties of pressure, volume, and temperature. We discover, well, Boyle discovered and others discovered that their values satisfy the Boyle, Marriott, Charles formula. And then, as we saw, we have good reasons to believe that the counterfactual, if this gas were in appropriate conditions, it would satisfy BM formula. The counterfactual has a truth maker, that is, well, among its truth makers, a power. Its most important truth maker, a power. Then, we attribute to a gas the power Bm, Bm stands for Boyle-Marriott, to remain in such a state if in equilibrium. Such power is discovered a posteriori through its observable manifestation. Okay, so if we define a gas in this way, so this is an analytic definition, which is necessary. So if X is a gas, then it exemplifies observational properties, and it also exemplifies or instantiates a specific power, which is a primitive power. It's an undefined power, okay? Because the biconditional definition doesn't hold, as we saw. So how do we define the primitive power PBM? Well, according to the formulas, the logical formulas presented above, we have that if X instantiate this power, then there is a K such that, etc., then we have the satisfaction of the Boyle formula. Okay? From this, we logically infer that necessarily if X is a gas and has a certain value of pressure and volume and temperature and so on and so forth, then it will instantiate a specific relation between the values of its pressure, volume, and temperature. Then we drop the box here, and we have the extensional scientific law. We can, here of course we have gas, but we could drop P here, that's not a problem. And then we have also, if we can derive from the first formula here, the formula which is the counterfactual, which is grounded by the so-called Boyle scientific law. Okay. Now let's take another example. So, well, again, there is according to Bas van Fraassen, there is an ontological problem of identification. That is, what is the reality in nature which allows us to identify universal statements as laws, okay? What is the truth maker of the proposition, this is a law, and this, the Boyle-Marriott law is a law of nature? Well, according to my view, powers, real powers, allow to solve the ontological problem of identification. Now, what about the contingency of laws? We have strong intuitions, and it's easy for us to imagine worlds in which there are gases, just like our gases. They have the same properties as our gases, but the relations, the relations between the mathematical relations between the quantities, that is, the values of pressure, volume, and temperature, are different. They are not the same as they are in our world. Like they are, for example, as I indicate here, there are, like, PV is equal to P is equal to KT to the square, right? You can imagine that. I mean, that's not a problem. These are imagined worlds. They are not concrete worlds, they are real worlds, but they are imagined worlds. Of course, those gases which are very similar to our gases, they wouldn't be gases because they wouldn't instantiate the same power. They wouldn't instantiate the same power as our gases, because our gases, they instantiate the power to behave according to Boyle law. But those gases in the imagined world would behave in a according to another mathematical formula. So the gases in the other world will be other particulars. Now, according to me, the categorical properties P, V, and T that we observed in our world, that's what we mean by those properties. And I don't see any reason why we couldn't take those categorical properties, P, V, and T, and also a sphere, to be the same in all imagined worlds. That's what we do, actually, when we imagine a world in which gases are just like our gases, but they behave in a different way. So I know that this is perhaps a strange contention, but I take categorical properties to be the same in all possible worlds. I know, of course, I perfectly know that according to standard construal, categorical properties are quantities and they have a primitive identity which makes them the same in all possible worlds, but they are not the same in all possible worlds because there might be possible worlds in which they don't have the same causal, whatever, function, roles, and things like that. Now, I don't see why the same properties couldn't be related by different relations in the same way that this is certainly true for spatial properties, but I think that it's true also for the properties such like pressure, volume, and temperature. But I know that it is controversial, but this is an unusual contention. But I think it can be defended if you take this world as being the only world that exists. The other possible worlds are just fictions, imagined worlds. And in those imagined worlds, I mean, pressure, volume, and temperature, they have the same value of pressure and volume as they do. And if you think that there are pressures which are different in other worlds, but then there are other properties that are not our pressure or our volume or our temperature. But this view allows us to satisfy a strong intuition if we distinguish laws from nomological formula. So in this imagined world, we would have a different nomological formula. And in this case, it's perfectly possible that you have different nomological formulas in different worlds. Now, how about the necessity of the laws that we indicated before? Well, in our world, we have this law of nature. I mean, the customary scientific boy law, right? And then it's necessary, but in those other imagined worlds, there wouldn't be gases, as I said, identical to the gases in our world. So such proposition would be vacuously true, but nevertheless true in those imagined worlds. Okay. Let's take another example now. Let's set aside the distinction between fundamental and not fundamental laws. Now, all particulars which instantiate the categorical property of charge, Q, interact according to Coulomb's law formula. This is a quantitative functional law. Therefore, if two particulars have let's say, positive charges of some specific value, they will repel each other according to this Coulomb formula. So we have here the formulation of the law of nature, which is the law, the Coulomb law. And in this case, the well, you have the definition of you have the definition of a power, which is the power to attract or to repel, which is defined, which is not defined, but which implies that if a particular instantiate this property, then it will, and if it has a charge, and if two particulars, both, well, maybe I noticed that it might be necessary to reformulate this formula a little bit here. But the idea is this, that a specific particular which has a charge Q has the power to attract another charge by means of a specific formula. So the power is a quantitative power. It's a general power of attracting or repelling charged bodies according to the Coulomb formula. And the property of charge Q is distinct from a property PC, the power disposition PC. So this view I submit can solve two important problems faced by any theory of laws, namely the problem of quantitative laws and the problem of conservation laws. If charge is construed as a power, then a specific power corresponds to each value of charge. So we have what is called in the literature a multi-track disposition. So for each value of charge, there will be a specific disposition, namely the power to attract another charge according to a specific value of force. Okay. From this, we cannot get the scientific laws as they are formulated in scientific theories. Clearly, it wouldn't be a law to say that when we have two charges of each 1 Coulomb, say, it's a very big charge, but if 1 Coulomb distant from 1 meter, then we have the specific force. So we'd have an infinity of such laws. This is highly counterintuitive. And from the infinity of such pseudo laws, we cannot get the scientific laws as they are usually formulated in scientific theories. Vetter has a discussion about that, and studies Psilos and Stavros and Vasilos have also a beautiful paper, by the way, which has just been published on this issue. So we cannot solve the problem of the functional laws in this way. So the solution I propose is to distinguish charge mass from this categorical, which are categorical properties, from power, the power to manifest a formula, a quantitative formula, a mathematical function, between which is an equality and puts a constraint on the values that can take charge and distance in this case. So if the manifestations of powers are nomological formulas, and if any value for the quantities are included in the conditions of manifestation, then the problem of quantitative laws, that is laws which mention a quantitative function between variables, in my opinion, is solved. Now, how about conservation laws and symmetry principles, which are very important in physics? Well, according to me, they supervene on functional laws by means of Noether's theorems. So if a system manifests a nomological formula, NM stands for nomological formula, then it will necessarily also manifest the conservation law associated formula, which is implied by the invariance of the nomological formula under certain transformations. So the conclusion is this, that's perhaps a too easy way to solve the problem of conservation laws, but I think that's, that it works. So the general conclusion now is this: natural powers as defined, and not laws, because laws are proposition, are the source of the movement in nature, and the movement and regularities as described by the nomological formulas. Powers and not laws play the governing role in nature. And this is my conclusion. Thank you very much. I look forward to the questions, because I am not quite sure, to say the least, about the many things I said in this talk. This is work very much in progress, and I keep changing my views very quickly on several issues. Thank you for your questions.
Thank you very much, Michel, for this very clear and very plausible, I would say, account. So there certainly will be questions. You either can ask to ask a question by voice or write it on the chat, please. Okay, Vincenzo Fano. Oh yes, you can raise your hand also.
Can you see and hear me?
Yeah, I see you, yes.
Oh, hi, Michel. It is wonderful to see you, even if it is only in a virtual form. Yes, your presentation was very, very interesting, but a bit too difficult for me, because I am old and not very smart, So I was not
just
able.
Just like me. I'm even older.
Yeah, but you are young. From a mind point of view, you are younger, because you are a pensionist. I have to feel a lot of stuff with words and bureaucratic, and so I cannot think very much. Okay, but I think it is a very general observation. Your presentation was very interesting, a very general presentation. I have the feeling that, but perhaps I am saying something not correct, that all people that love science and have a certain acquaintance with what science is, it is difficult that they have a regularist approach to scientific laws, so they have in general a necessitarist approach like yours. But my feeling is that when we attempt to say with a lot of or much more precision in which sense we are necessitarist, this task is very difficult, because each formulation in a certain sense must say something about how the world is constituted, and the world is constituted in a way that is in different situations different. And so it is easy to find in a certain field of science a counterexample to your formula. I am not able to find a counterexample to your account, but I have the feeling that to attempt to say with a lot of precision for which reason we are really we are actually not regularist but necessitarist is a bit dangerous, because for a regularist it is possible to find in a part of science, in a part of reality, a counterexample to that kind of account. I don't know if I was sufficiently clear about my point. Anyway, thank you very much for your presentation. It was very interesting. In a few minutes, I have to go to lecture. I listen to your answer. I say goodbye to you. It was wonderful to see you.
Okay, thank you, Vincenzo. Okay, look, well, yes, I know, but that's the job of philosophers. Try to find a general account of things. In this case, a general account of laws, and in the case of scientific laws, it's important, of course, and I try to do that to to stay as close as possible to what laws are in the context of science. There might be some counterexamples. Then you said that you cannot at this stage provide a counterexample. There might be possible, of course. I cannot deny that here. But then I am waiting for counterexamples, and then if there are examples which at first sight contradict the view I'm trying to defend, then I'll try, as most philosophers usually do, I'll try to accommodate my philosophical view to the counterexample and not abandon it. That's what philosophers usually do. I mean, they stick to what they believe to be correct or what they came to believe, then try to adapt their philosophical theory to the counterexamples. I know that's a very general statement, but that's well, in the absence of precise counterexample, I cannot say more. Thank you, Enzo, and ciao.
Thank you. Ciao.
Okay, more questions? Anybody wishing to ask a question?
Mario, I have a question.
Yes, please.
Sorry for my webcam that is not working now, and I don't know why. I have a very short question because I am not an expert on these issues. It seems to me that dispositions, at least in ordinary language, have always assumed an essentially predictive function, because they express certain irregularities of the world. For instance, if I know that a certain mushroom is poisonous, dangerous to health, I also know that if I eat it, I die. It seems to me that this predictive function does not bring with it an additional informational content, in addition to that distilled from events that have already happened. Because it's my past knowledge of mushrooms that allows to me to prevent eating dangerous mushrooms, obviously.
Yeah.
The predictive function belongs more properly to categorical properties. For instance, if we have certain substance that we have never made interact, from their chemical structure, we can maybe predict the result of the experiment. Postulating instead the existence of causal powers contained in them does not allow us to predict much more. From this point of view, it seems to me that causal powers are sterile, are fruitless, or I'm wrong.
Yeah. Okay. Thank you, Giovanni. This is a very standard objection that you can do with the powers, but then if you try to solve the identification problem, as Van Frassen said, that if you try to solve the identification problem using only regularity resources, as empiricists try to do, then you fail. And that's why Van Frassen bites the bullet and says that in science we simply have to do without laws. I mean, laws are not indispensable to understand science. But if you believe that the ontological identification problem is important, then I don't see how you can solve it without resorting to powers.
Okay, thanks.
Vasilis, to you.
Yes. Thanks, Michel, for the interesting talk. I have two questions for you.
Okay.
The first, the first is this. It seems to me that you have doubled the properties of each object. You say that there is a gravitational mass, which is categorical, and there is a distinct property of the object, which is the disposition to attract other massive objects.
Yes.
The first point is, what reason do we have to think that there is the gravitational mass as categorical property in this case? In your account, this is the first question. The second is...
Let me sorry to interrupt you.
Yeah.
I just want to answer your first question now, if it's okay. As I explained, if a property is observable and is observed, then it's a categorical property. And I think that's something which is defensible, because on the one hand, modal properties, they are not observable, and on the other hand, when you observed something at a certain time, then you see, let's take the sense of sight, you see that the thing or the particular is having a certain property. It's not doing anything. I mean, it's having a property. So it has a particular value of mass, irrespective of the relations that it can have with other masses. That is the attraction of other masses. So by means of experience, you get at what things are at a certain time, and that's what a categorical property is. Categorical property says what the particular is, and not what it does. I mean, that's a standard. Maybe I should have said that more in my talk, but that's this important distinction between categorical and dispositional properties. I know this is controversial, because to be observable, to claim that mass, for example, gravitational mass is observable, you don't observe gravitational mass as you observe color red, for example, or the sphericity. True. But on the basis of experience, as I showed, you can have a good claim in favor of the truth of a statement that says that this gravitational mass is bigger than this other gravitational mass.
No. My problem is other. That I think. Okay, you say that the laws are propositions, and laws of nature are necessary proposition. Okay.
Yes.
Okay. So laws are not entities.
Laws
are not entities in the world.
No. Okay. Yeah.
Okay. Now, if we double the properties as you do, if you have a categorical gravitational mass and a modal property, a modal disposition to attract other bodies, then the role of the law is played by the modal property.
Yes.
Okay, but you define in a way the power in such a way as to incorporate the law in it.
Yes.
I don't feel that you can solve the functional laws problem in this way. Because the problem is how can go from power to regularity and to law, and it seems that you incorporate in the nature of power the law.
I incorporate in the power the nomological formula, which is the manifestation. So the power to attract is the power to attract according to a certain mathematical formula. And when this attraction between two masses of a certain value, of certain values obtained, then you have the manifestation. But I make a distinction which is very important, I think, between the nomological formula, which describes the manifestation, and which is included not in the definition of power, but which is implied by the instantiation of a specific power by a particular. The manifestation is a nomological formula, but it's not the law.
Yeah, but can a power, which is a property, can a power have a manifestation which is a mathematical formula? This is my problem.
Why not?
Because the manifestation is something in the world. It's a regularity or a fact or something like that.
The regularity is described by the mathematical formula.
But the manifestation is the regularity, not the formula.
The manifestation is the regularity, but the regularity is described by the mathematical formula. The regularity, each instance of the regularity is the instantiation of the mathematical formula.
Okay, to monopolize the discussion. Okay, thank you very much.
Well, but I take your point. I'll think about it, because I really, as I mentioned, you wrote a paper, a very interesting paper with the studies and Stavros. So, but your views are quite different from mine. But I don't see why I shouldn't take a manifestation to be just in general, because when you could talk of a manifestation, even in common parlance, you don't specify this specific manifestation. When you talk about the dissolution of sugar, there are many ways in which the sugar can dissolve in water. There are many ways in which the molecules of a piece of sugar can interact with the molecules of water, etc. So any manifestation is general in a sense. So when I characterize a power by means of a quantitative manifestation, it's about the same thing, it seems to me.
Okay, thank you.
I know you disagree, but
Okay, okay, thank you.
Any more questions?
You didn't have another question?
If you had another question, Vasilis, you are welcome.
I think Stavros is speaking now.
Okay.
Yes. Can I ask
Hi,
something?
Stavros.
Hi, Michel. Many thanks for your presentation. It was excellent. So this is a very general question. So in your framework, you accept categorical properties. You say that dispositional properties are not observable. What is, according to you, the reason that for one to prefer your framework and not Armstrong's framework? So, for example, for Alexander Bird, all fundamental properties are powers, and it seems that if Bird can explain laws as grounded on powers, then this is an argument that powers can do some work in metaphysics. So in your framework, what would be the main reason to prefer this framework and not the ADT framework?
Okay, thank you. I think that one reason is that the necessity relation in Armstrong ADT, Armstrong Thule account, the necessity relation is mysterious and doesn't have a connection with the experience. It's the first reason. The second reason is that in my account, powers are intrinsic to particulars. That is, in ADT account, what makes a property powerful, so to speak, is the necessitation relation, which is external to the properties. Okay, so a law according to ADT, it's a reality. A law belongs to the furniture of the world. It has the form A, N, B. A is a property, B is a property, and N is the necessitation relation between properties. Okay, and then in this case, the modal effectiveness of properties A and B is endowed to them by the necessity relation. Whereas in my account, powers are intrinsic properties of particulars. Okay. And these intrinsic properties of particulars, it seems to me they are not mysterious. I think that we have a clear grasp of those powers or dispositions by means of our inner experience. And on the other hand, we have arguments which are drawn from experience in favor of the existence of such powers. For example, we know we can get knowledge of the existence of those powers because we know that sugar is dissolved in water. That we put sugar in a dry place because we want to use it to put in our coffee some other day. Because we know that the vase is fragile, that we take good care of it, etc. So I think that an advantage of my account with respect to Armstrong account is that it is closer to experience. I know that Armstrong works hard to have this necessity relation grounded in experience because he identifies it with the causal relation, but I don't think it's very satisfactory for several reasons.
Okay, thanks.
Thank you.
Thank you. It is time for questions. Perhaps I might ask one or two questions myself, and then there will be time for more, I think. Now, Michel, as you mentioned, you know that I tend to think that some way or other we need an inference to the best explanation to argue for the existence of things we cannot directly observe. And of course, you said that powers are not observable. And you claim that we can have reasons to believe in their existence by observation, induction, and the possibility of falsifying our claims about powers. But very generally, I think that your account of powers includes a mention of necessity, modality, and modality is never something which we can observe. And what we cannot observe, of course, we cannot make inductive inferences about. So it's very unclear to me how, of course, you can without inference to the best explanation, you can conclude to a scientific law, but not to powers. Okay, but this is an objection which you knew, I guess, more or less. Another question which is new.
Let me, Mario. Sorry to interrupt you, but maybe I can answer to that question.
Okay, why not?
First. Okay, yes, you raise a difficult point. I'm aware of that. The question is, how can I, from experience, which is not modal, there is no epistemic observational access to possibilities and necessities and so how can I say, from the basis of what I observe, conclude that there are powers and properties which endow the particulars which instantiate them the possibility of doing some things. Well, I can't say more. I cannot say more than what I already said. That this is the way we experience the world, and that is the way we formulate our experience. We formulate our experience about some regularities, observed regularities in terms of counterfactuals. We know on the basis of experience that we have to be careful with phases, because if we hit them, they will break. And then if we don't hit them, if we had we hit a vase, then it would have broken. And this kind of counterfactual is usually formulated in terms of modalities. And if this kind of counterfactual has a truth value, I don't see how you can avoid recourse to powers. So, of course, a crucial role is played here by the truth maker principle. This truth maker principle, according to me, can be vindicated on the basis of experience as well, because of the experience of error. That is, if you have some beliefs, you believe in the truth of some propositions, then your experience makes you to obliges you to change your view. And counterfactuals are falsified. I mean, they are falsifiable. They could be falsified. They have some truth or falsity content. In this case, accept that. Then it seems to me you should accept that there exist powers, other powers which would falsify there exist powers which would make true. Which would make true the conditional counterfactual. I know that it's a difficult issue. That there are many philosophers, most philosophers actually, like Barbara Vetter and the people who have been thinking a lot about modalities, they try to justify the existence of powers by resorting to the inference to the best explanation. But at least I try to defend it on the basis of inductive reasoning. I know it's difficult, but at least I try. But it's a major difficulty. I acknowledge that.
Right. So you're saying that experience tells us that that some counterfactuals are true, and in fact we know they can be true or can be false. So therefore, they must have truth maker or false makers.
Yeah.
And what else is a truth maker for a counterfactual, if not a power? So this is your argument, right?
Yeah.
Right. Well, I suppose that perhaps in the inference from experience to counterfactual, there might be lurking somewhere an implicit kind of argument to the inference to the best explanation.
Yeah.
And perhaps, and as far as the truth maker, could not the truth maker of a counterfactual or a false maker of a counterfactual be just an observation when we observe that the counterfactual has not borne out? Isn't that just a false maker?
Yeah.
Okay, let me ask, if you like, the other question. Now, if I got you correctly, you took an anti-essentialist view about particulars, okay, and also about kinds, right? So you said that gas does not have, it's just particulars which have certain properties, right?
Yeah.
So no essential properties which define a gas.
Yeah.
Okay.
Just properties which happen to occur together.
Right. Okay. How properties are together, but they are not essential. Then toward the end of the talk, you asked the question why laws are contingent, right?
Yeah.
And you gave the whole formula of the law, and you said, okay, if we have a different world in which we don't get those manifestations,
yes,
the formula of the law is still true, but only it is backwards is true, because it's about gases.
No, it's not the formula is vacuously true. The whole formula. I mean,
right.
The law of nature is vacuously true.
Right. The whole thing, not just the nomological formula. Okay, that's vacuously true because in that world there are no gases, right? And therefore it's true, but it applies to nothing. But now, why in that world there are no gases? Of course, there are things which resemble gases very much, but simply they do not have the powers which gases have on the Earth.
Yes.
All right. But then, aren't these powers essential to gases? Since you say that things very closest, very similar to gases, but that do not have those powers are not actually gases. So those powers are essential properties after all.
No, it's it's not. It's only nominal. You know, it's not ontological. It's just that there are contingently there are particulars in our world which instantiate properties like pressure, temperature, volume, and specific powers. Okay, and those are gases in our world. But there is no necessity that links the properties of pressure, volume, temperature to a particular power.
Okay, but how about another world? A world in which they have the same categorical properties as gases have in our world, but they don't have those powers.
Yes.
Then you say they are not gases, right?
Yeah, they are not gases. I mean, they're gases are, you know, if you wish.
So that means that
they are the particulars. They are the particulars because they have other powers.
Okay, but that means that having those powers is part of the definition, that is part of the essence of what you call gas.
Yes, it's a definition. It's a definition, but it's not an essence because there is no necessary link between the properties. It's a nominal essence, if you wish, but it's just a tag, a word that you use to refer to a set of properties.
Okay, thank you.
Yeah, but I think that's defensible, you know. Just yeah.
Okay.
Thank you for your questions.
I think we may have time for another question.
Everybody agrees.
Yes. Okay. Well, if there are no more questions, I would like to thank everybody for taking part in the seminar, and Michel above all, of course. It was very pleasant, and looking
Thank you
forward
very much.
to meet again.
Grazie tante, grazie tante.